So students, after the key mapping, we will do encryption or we can do decryption by using the same key. But there are some rules for encryption and you have to be very attentive for understanding of these rules. What we will do, whatever we have a plain text, we will create the pair of two characters bigram in computational term. We used to say it as a bigram. So let's start with the example. Suppose we have Pakistan as a plain text. So what we will do for encryption, we will create the pair of two characters, that is PAKISTANN. So we have to create the pairs of all characters. But fortunately, we have these characters that are even in number, and we have created the pairs of whole characters. But that is also possible that we can have such numbers that are odd in number. For example, we can have test T, for example. So we will create T, E, S, T, and Y. So here is a problem that we don't have any other pair with the Y. So for this situation, in PlayFair Cipher, we will write a filler. Filler can be any number, any character in whole alphabets. For sake of simplicity and understanding, usually the people use the same character as X as filler. So X is filler, and whenever we will have such situation, we will write X at the end, and that will be defined by the algorithm as well. That whenever we will decrypt it, we will actually ignore the last letter, that is X. So this is the first example we have seen here, that how we can develop the pairs of whole plain text. But there is different problems in this scheme as well. So, for example, we have balloon as a character. So for making the pair, what we will do, we will create BALL and ON. That is the ideal situation, but that is wrong. We need both letters should be different in each pair. That is another rule. So rule number 3 is when we will create, actually rule number 4 is when we will create the pair of plain text for encryption, we have to check the characters of both pairs should be different. But in this case, we have seen that BA is one character, but we have L and L. Whenever there is such kind of situation we will break it. How we will break it? We will add filler between these characters. So filler is always X. So we will write L and L with X, and whole characters will proceed further. So for this balloon, we have BA, then we have LX, and remaining characters are LON. So LO will be next value because L is now separated with the other L, and we have N, the single character left at the end. And I have already told you by the testy that we will add filler at the end of this character as well. So we are not doing encryption right now. We are just creating the pairs. Encryption will done in the next phases when our pairing will be done. Another example is here, that is money. So that is MONEY, and we already have learned that we have to write the X. So rule of encryption is in your book: if a pair is repeated letter, insert filler like X, and I have also added that if we have odd numbers, we will need to add filler at the end. So let's take another example and use another example for pairing and having such kind of issues and problems. We will break the values, same values, by adding the filler in it. So this is the rule number 1. Now come up with the rule number 2. What is rule number? Rule number 2 is that if both character, now we have started the encryption. We already have created the 5 by 5 matrix. Supposedly this is my very neat and clean matrix. So what is the method to make a pair of encryption in pair of encryption? So what is the rule number 2? In rule number 2, they said that if both letter fall in the same row, that means if one character and other character is in the same row, you have to replace each with letter to the right and wrapping back from start from end. That means whenever there is the two characters, because we have created the pair, if both characters are in the same row, we will write the value at the right. For example, in this case, we have this character, we will have this character. So for row, we will check the right letter to the right. And they have said that if the letter is at the end of the rows, for example, here is my character. I'm going to use another color for better understanding. For example, if the character in one row is here at the end of this letter, for example, I have one character here and one character here in one row. So at the right, there is no character because the metric is n. So what we will write, they have said that we have to wrapping back to start from, and that means we have to wrap it and to the start. So this complete row will actually rotate as the shift function. And if we have x, suppose we have a here, so we will write x a in, with replaced with the x. So one first rule is we have to write the right letter if there will be both plain text letter in the same row. So that is a tricky part. Don't get confused so much. I will explain it with a complete example. A whole idea will be clear in the coming slides. So what is the third rule of PlayFair cryptography? They said that if both letter falls in the same column, replace each with the letter below it, again wrapping to top from bottom. So if we will have both letters in key as in one column, we will write the letter whatever is the below, and similarly we will wrap it with just like the letters in the same row. And on the other hand, we have another rule for encryption, the fourth rule, that is the last rule of whole PlayFair cryptography, and we will conclude it by using one concrete example. Fourth rule said that otherwise each letter is replaced by the letter in the same row and in the column of each other letter of the pair. What does it mean? That means if we have two separate letters in different rows, what we will do, we will actually create a small grid like this. This is a small grid. We will write, check the small grid here, and we will replace the letter where both letters will intersect here. For example, here we have A and here we have C. So we will write A instead of X, and for this X we will write C. So this small grid matrix will tell us that what is the cipher text.